Welcome back to another lecture. So, and this is a lecture, I'm going to try to go through some example, and an example that you see in the front of you, I highlighted a bunch of elements, and I'm going to ask, find the hybridization geometry and the bond angle bond angles that I'm going to assign. Okay, we're going to start from the left side and with carbon. And the first thing I'm going to do, okay, I'm going to label the sigma bonds that I have for carbon. So I see a sigma bond, 1, 2, 3, 4. I have 4 sigma bonds. Okay, so we have 4 sigma. Okay, so sigma plus lone pair, we got it equal to 4. Sigma plus lone pair, the answer, we got it equal to 4. Because we have this one equal to 4. So what's going to be the hybridization? Always S1. So you need to add something to S, and you need to add the 3 from it, and that's going to be sp3. So the hybridization, it will be sp3. Okay, what's going to be the bond angle? Expected bond angle, okay, for sp3. If there is no lone pair, and in this case, we don't have a lone pair, we have a 0 lone pair. If there is no lone pair, theta for hydrogen, okay? For example, between these two hydrogen, I'm going to here say between those two hydrogen, theta, I expect theta to be around 109. So theta is going to be around 109.5 degree. Okay, you can assign theta somewhere here, and that theta also is going to be around 109, 109.5. Okay. What's going to be the electron and molecular geometries? Electron and molecular geometry for both of them. So I'm going to say, because I don't have a lone pair, electron geometry is going to be equal to the molecular geometry, and both they will be equal to tetrahedral. Okay, tetrahedral. Okay, because we don't have a lone pair. Now let's switch to the second carbon. Okay, second carbon, we have 1 sigma, 2 sigma, 3 sigma, and we have a pi. We don't care about the pi. Okay, we don't care about the pi. So carbon is octet. Clearly, carbon is octet. So how about this? We have 3 sigma. And how about lone pair? Lone pair, we have it equal to 0. So sigma plus lone pair, we got it equal to 3. And because we don't have a lone pair, we got it equal to 0. That means electron geometry is going to be equal to the molecular geometry. And I got them equal to 3. So this is going to be trigonal or trigonal planar. Okay. Trigonal or trigonal planar. Okay. Now, what's going to be the bond angle? Okay. You have an atom that attached to, okay, 1B and say 2 more B's there. They can be identical or non-identical. What do you expect the bond angle to be? The bond angle is going to be 120 because you don't have a lone pair. So theta is going to be around 120. Okay, so I'm going to say this theta is going to be around 120. Okay, how about the hybridization? Okay, the hybridization, okay, you say I have 3 pairs. I'm going to use 1 from S. I need 2 more orbitals, 2 from P. So you will say, we're going to get 3 orbitals of always S1. How many we need to add to make it to 3? Okay, we need 2 from P. So you go 2. Okay, keep this one in your mind. When you add these 2 numbers, the exponent, when you add them, they need to be equal to sigma plus lone pair. So sigma plus lone pair is going to be equal to S plus P. Always. These 2 digits, if you add them, they need to give you this number. Okay, if I go back, okay, when I added these 2, 1 plus 3, that one gave me 4. Okay, that's always solid, always. Okay, let's zoom on. Okay, let's zoom on oxygen. Okay, oxygen this time, we have 2 oxygen. The first one, the pink one, is a bit a bit kind of like tricky. Why tricky? Okay, you need to ask yourself whether oxygen is acted or not. Clearly it's not. Okay, how do you know, or how do I know? Okay, how about this? Let's draw a circle around it. Okay, how many electrons do we see? 1, 2. Okay, we made 2 bonds. Okay, so 2 plus 2, 2 plus 2, 4. How far we are from 8? We are 4 electrons far from 8. So what do I need to do? I need to add 2 lone pairs to oxygen. Okay, for your knowledge, in organic chemistry, we do not show, okay, we don't show lone pairs on nitrogen, oxygen, fluorine, bromine. Okay, we don't show the lone pairs. Why we don't show the lone pair? Because it's easy to to draw the molecule and move on. So how do I know whether it's acted, or how do I know whether I have a lone pair or not? Always you have to keep this element like carbon, nitrogen, oxygen, fluorine, chlorine, bromine, keep them acted. So keep adding lone pair to them until you make it to 8. Okay, now let's talk about oxygen. Okay, how many sigma bond do we have? We have 1 sigma bond, and that's a pi bond. So, okay, we have 1 sigma. How about lone pair? Lone pair on oxygen. On oxygen, we have 2 lone pairs. Okay, so sigma plus lone pair, I got it equal to 3. Okay, this time we do have lone pairs. So that means electron geometry is not going to be equal to the molecular geometry. Okay, next, what's going to be the hybridization? Hybridization is going to be, okay, 1 from S, 2 from P, you get 3 orbitals of S1 and P2. So the hybridization is going to be sp2. Okay, sp2. But what's going to be the electron or molecular geometry? Electron geometry, because you got the hybridization, sp2 must be trigonal planar. Trigonal planar. So sp2 always is going to be trigonal planar. Okay. Next, how about the electron molecular geometry? What do I see? I see an oxygen. I see an oxygen attached to carbon. Okay, I see an oxygen attached to carbon. Okay. What do you call it? Clearly, that's going to be linear geometry. Okay, because I see just 1 line, so it will be linear. So the molecular geometry, it will be linear. Okay, next, what's going to be the bond angle? Okay, what's going to be a bond angle? Which bond angle? Okay, let's say we're talking about this bond angle, or maybe that bond angle. What should I call it? I have carbon attached to 2 atoms. So technically you have carbon attached to oxygen, and then 2 species, whatever here. Let's call it X1. That one is X2. And what's going to be the bond angle here? Theta clearly is going to be 120. Okay. You might say, why don't you include the lone pairs on oxygen? Are they going to affect the lone pair, the theta here? No. Why? Because your central atom is not oxygen. The central atom is carbon, and the lone pair is not sitting on carbon, it's sitting on oxygen. Lone pair, if the lone pair is sitting on the central atom, it will shrink the bond angle. Right now, the lone pair is sitting on oxygen, so who cares? It's not going to affect the bond angle. Okay. Next, oxygen. Next, oxygen is not acted. Okay. Again, draw a circle around it. Okay. You're going to show 2 lone pairs on oxygen. Okay. Now, 2 sigma. This is the sigma, first one, and that's the second sigma. And how about lone pair? 2 lone pairs. Okay. two lone pairs. So electron geometry will not be equal to the molecular geometry. Okay, sigma plus lone pair, I got it equal to 4. That means the hybridization is going to be sp3. So, okay, 1 from S and 3 from P. I get 4 orbitals of S1 and P3. Okay, expected electron geometry will be, because the hybridization is sp3, it should be tetrahedral. But what's going to be the geometry? The thing that I see oxygen with 2 lone pairs and attached to 2 different atoms. Okay, what should I call it? It will be bent. Okay, so that's going to be bent geometry. Okay, and so the molecular geometry will be bent. I have 2 lone pairs. Okay, I have 2 lone pairs. So now what's going to be the bond angle between these two? Okay, let's call it theta. So I'm going to erase this. Okay, I want to see what's the bond angle here. This theta. That theta, it will go down from 109 by 4 degree. Why 4 degree? Because we have a lone pair. We have 2 lone pairs, actually. We have 2 lone pairs. So we're going to say from 109.5, we're going to subtract it by 4 degree. So it's going to be something around 105 or 114.5. So it's going to be around 105. Okay. How about next carbon? Okay, next carbon. I see a sigma here. Sigma, that's pi, and this is sigma. So 3 sigma and 1 pi bond is exactly similar to this one. Okay, 3 sigma and 1 pi. So hybridization for this carbon, okay, because you got 3 sigma and 3 sigma and 0 lone pair. Okay, so the hybridization, it will be S1, P2, and both electron and molecular geometries, they will be equal, and it will be trigonal or trigonal planar. And theta, and okay, theta, which theta? For example, okay, let's say this theta. That theta expected to be around 120. And theta that we had for oxygen, that theta we said is going to be something around 107. Cool. Okay. Now let's zoom on nitrogen atoms. Okay, nitrogen atoms. Okay, which nitrogen? I'm going to start with the top one. The top one, it has sigma here. Sigma, sigma, sigma. That's 3 electrons plus 3 sigma bonds, so it will be 6. Nitrogen is missing 2 electrons to be octet. Here you go. Let's show lone pair on nitrogen. So I added a lone pair on nitrogen. Added lone pair on nitrogen. Okay, so we have 3 sigma and 1 lone pair. Sigma plus lone pair, we got it 4. So electron geometry, because we do have a lone pair, is not going to be equal to the molecular geometry. Electron geometry, because we got 4 pairs, it will be tetrahedral. Okay, why? Because hybridization will be 1s plus 3p, it will be sp3. And if the hybridization is sp3, always will give you, okay, always will give you electron geometry equal to tetrahedral. But how about the molecular geometry? Molecular geometry, because you have a lone pair, okay? You have a lone pair, okay? The top one is missing, and if I connect these three atoms to the top one, it will give me a pyramid, and the base is made of three atoms, so I'm going to call it trigonal or trigonal pyramidal geometry. Okay, how about the bond angle? The bond angle from 109.5, I'm going to drop it by 2 degrees, and that's going to be 107. Okay, the previous one, I think I made a mistake. I wrote 107. I don't know why I wrote 107, because we have two lone pairs. It should be 105. I'm sorry about this one. This one, 105. Okay, let me double check here. Yeah, should be 105. Cool. I'm sorry, I made a mistake, and I wrote it 107, because we had two lone pairs. Here we have one lone pair, so we're going to drop it by 2 degrees. Okay, and last nitrogen. Last nitrogen. Okay, what do we have? We have a sigma, and that's a pi bond. Is nitrogen active? Let's double check it. 1, 2, 3 electrons, and it's making 3 bonds, so it will be 6. How far we are from 8? Why do I say 6? Just simply draw a circle around this, and you're going to see 3 electrons inside the circle. You made 3 bonds, so it will be 6. How far we are from 8? We are 2 electrons far from 8. So what do I need to do? I'm going to show it. I'm going to show lone pair on nitrogen. So our nitrogen has a lone pair, okay? Has a lone pair. So we're going to say this. We have 2 sigma and 1 lone pair. Sigma plus lone pair, we got a 3. So what's going to be the hybridization? It will be 1 from S, 2 from P. So that's going to give you sp2. S1 and P2. Okay. sp2 hybridization will give you electron geometry equal to trigonal or trigonal planar. Okay. But we have a lone pair. So what's going to be the molecular geometry? Okay. That one is going to be equal to, I have an atom like A attached to 2 outer atoms, but there is a lone pair here. So what do I see? I see a bent geometry. Okay, bent. So I'm going to say the real geometry will be bent. Okay, if it's a bent, then what's going to be the bond angle? I expect the bond angle to be 120, but I have a lone pair, and that lone pair is going to push them down. It will push the bees and will force them to get closer. So your bond angle, which bond angle? This bond angle, that theta. It will be something less than 120, but is bigger than 90. Less than 120, but bigger than 90. Okay, we good? Okay. I have a question here. And the question is saying, okay, let's make this one. Okay, I'm good for a second. Okay, okay, I'm gonna change this one. I don't want you to get confused. Let's make this one 1. Okay. Question 1 for this lecture. Okay, question 1, it says, what's going to be the hybridization of oxygen? Okay, and to determine whether it's a polar or non-polar. Okay, I'm going to do one example for you, and I will leave the question for you. Okay, so let's say you have such a molecule. You have CH3, O, CH3, CH3, O, and this one is going to C2H5. Okay. 1, 2. Okay. The first molecule, it says you have a carbon attached to 3 hydrogens. Okay. Then you have oxygen, then oxygen attached to carbon, and carbon attached to 3 hydrogen atoms. Okay. What I want you to do, okay, just simply draw circle around those two and say whether they are identical or not. Clearly, they are identical. Next, your oxygen is not octet. So what do we need to do? We're going to add lone pair on oxygen. You're going to add lone pair to oxygen. Remember, we said if we have a lone pair or lone pairs, our molecule will be octet, will be polar, except when they are 180 far from each other. Okay, this one, if you check the hybridization for it, it's going to be polar. How do I know it's going to be polar? Because the geometry, real geometry for it will be this. I have sigma plus 2 lone pairs. So I get 2 sigma and 2 lone pairs. 2 sigmas and 2 lone pairs. Okay. Next, sigma plus lone pair, I got it equal to 4. Okay. What's going to be the hybridization? It will be, okay, 1 from S, 3 from P, you get S1P3. So the hybridization for oxygen, it will be sp3. Okay. This one's supposed to be tetrahedral. Okay. And for tetrahedral, okay, listen carefully. For tetrahedral, if you have 1, 2, or 3 lone pairs, it will be polar, providing you have non-identical elements attached to each other. Okay, and clearly in this case, I see carbon attached to oxygen and carbon also attached to hydrogen. But I want to say this, carbon is not identical to oxygen. So I have 2 non-identical elements attached to each other. Am I going to polar? Am I going to have a polar molecule? Okay. Is this one polar? Yes, that one is polar because I can cancel force of the lone pairs by force of the hydrogen atoms. Okay, those are that molecule, it will be polar. Okay, if that one is polar, then this one will be polar because you cannot cancel force of the lone pairs. That one for sure it will be polar. Okay, why is polar? Because the bond angle, what's the bond angle here? The bond angle is 109.5. We drop it by 4 degrees. Theta is 105. If your theta is anything other than 180, if it's anything other than 180, and you have a lone pair, that molecule will be polar. That molecule for sure it will be polar. So in this case, I'm going to say mu is going to be bigger than 0. Yes, they are identical. I have 2 groups identical attached to oxygen, but I do have lone pairs. Now, what will happen if I change it to, say, CH3, then oxygen, in that case, this group will not be equal to that group. This group will not be equal to that group. And of course, you do have also lone pairs. So not only you have lone pairs, 2 groups are not identical. So this molecule for sure will be polar. Okay. And the last example I want to mention, what if I go with this? Is this one polar or non-polar? Okay, how about this? Why don't you chop the molecule to 2/2? You put the line here and you ask yourself, okay, you're gonna ask yourself, is this piece identical to that piece? Okay, if the answer is yes, okay, this one will apply a force, and that force is gonna be, okay, identical to the second one. So the molecule will be non-polar. Okay. What if I have more than one carbon? You have more than one carbon. Let's say this. Forget when I say more than one carbon. Let's say we have a couple of carbons between them. Say we have those. Again, I'm going to chop the molecule. Okay. I'm going to chop molecule to 2/2. So where can I put the midpoint? The midpoint is going to be somewhere here. So in that case, this piece will be same as that, and that molecule will be non-polar. Okay, so I'm going to stop here. Thank you very much, and I hope this lecture is going to be useful and help you to understand how to figure whether a molecule is polar or non-polar and how to find the hybridization. As usual, I will see you soon, and take care.